Welcome back again to my channel Teacher Cool, and since we are done with the concepts of entropies in theoretical nature as well as the mathematical formulation of entropies in our previous lectures, let's take it further to the next level, that is comparing the entropy concept with the second law of thermodynamics. Entropy is the topic which we are done with, so we'll move forward. Now, entropy को सबसे पहले थर्मोडायनेमिक्स के सेकेंड लॉ के टर्म्स में अगर हम लिखें तो सेकेंड लॉ ऑफ थर्मोडायनेमिक्स स्टेट्स दैट ऑल द naturally occurring processes in nature tends to maximize the entropy. Being going through the previous lectures, this thing is not new for you. So this is the same thing, that is the entropy of the universe is increasing. This is the first official statement of second law of thermodynamics, which states that all the naturally occurring processes in nature will tend to maximize the entropy, and as a result the entropy of the universe will increase. So this is my you can say the official statement for second law of thermodynamics. Now we'll use the previous lecture's result, which said delta S was equals to the ratio of Q by T. Now this Q was basically the amount of heat exchanged, either it was being absorbed or it was being rejected to the sink. So इसको और generalized way में अगर मैं लिखूंगी तो that is delta S is equals to delta Q, the amount of heat exchanged at that particular temperature. So if I need to find the amount of heat exchange in terms of entropy, I'll say delta Q is equals to T delta S. इसको for smaller changes अगर मैं generalize करूँगी तो it is dq is equals to tds. I'll name this equation as 1. Now the first law of thermodynamics, if you can recall, it said the amount of heat energy exchanged was equal to the amount of work done plus the amount of internal energy change. So according to first law of thermodynamics, dq was equal to change in internal energy plus dw, which again we explained as du plus amount of work done given by pdv. This is my equation 2. Now if I compare the equation 1 and 2, it is the same amount on the left hand side. I can compare them. So I'll write comparing equations 1 and 2, I get dq, which is equals to tds, is also equal to du plus pdv. Now if I omit this dq part, I get tds is equals to du plus pdv. With this we are getting a new equation जिसको हम बोलेंगे it is the combined form of first and second law of thermodynamics. This is the combined form of first and second law of thermodynamics, and also this is the mathematical form. Now, suppose the question asks, tell me about the second law of thermodynamics. So, first thing we'll do is, we'll say that the official statement of second law of thermodynamics is that all the processes naturally occurring in nature are tending to maximize the entropies, and since we know that the entropy is, the change in entropy is given by the amount of heat exchange at a particular temperature, which is a constant. So according to that relation, we get dq is equals to tds, which is our first result. Then according to first law of thermodynamics, we get this equation, mathematical form of first law of thermodynamics. And comparing these two results, we get the third equation, which completely defines the second law of thermodynamics in comparison with the first law of thermodynamics, or you can say the combined form of these two laws of thermodynamics into a mathematical expression given by TdS is equals to du plus PdV. So this will be your complete explanation of second law of thermodynamics. Also at this point, I would like to add one more thing, that whenever we are saying it is the del Q by del T, right, we are talking about isothermal processes. These all are isothermal processes. That means whenever we are talking about delta S1 and delta S2 in a Carnot cycle, we are taking into consideration the isotherms, not the adiabatic part. Why we are omitting the adiabatic part? Because since we know delta S is equals to delta Q at a particular temperature, in case of adiabatic process, delta Q is 0. So we will get the same result, that is delta S is equals to 0, but the difference is, or you can say add-on is, in adiabatic processes delta S is also 0, delta Q is also 0. So we can say adiabatic processes can also be called as isentropic. Entropic, isentropic, that means every adiabatic process is also an isentropic process because there is no change in heat energy and there is no change in entropies. So this is a very small add-on with this whole topic. With this we are done with the second law of thermodynamics.